Welcome, Anatomy and Physiology. This is a PowerPoint and recorded lecture on going over the PowerPoint for the final. Yes, you do have a final. It's 100 questions. That is about 30 questions per section that we're going to cover. Your final is going to be on digestive, urinary, reproductive systems. 100 questions, multiple choice, couple true, false. Anatomy is going to be somewhere between at least minimum 50 to 60%. That includes labeling questions, so such as not necessarily labeling, but having to identify certain structures. So having somewhere between 5 to 8 structures and being able to, kind of how we've done in the past, nothing new. And then physiology being the remaining 40 to 50 questions or so. But it will not be over 100 questions. So you'll have 100 questions. Before I told you it's going to be comprehensive and include all, but it's just going to be now that things have changed, we learn to adapt. I don't want to stress you out too much with everything going on. So therefore, that's why we're doing this. We had no quiz or no tests on these. This is your test. So a little bit larger quizzes. Now you have these. This is going to be the first of a 3-part series. We're going to cover the digestive system in this lecture. Then we'll cover the urinary system, and then we'll cover the reproductive system. So as far as what to study, you have these recorded lectures, you have PowerPoints that will be made available online, you have the study guide that will be made available online, and you have the quizzes that I will email out. Now, the quizzes won't have answers to them because there's still a lot of people that need to make up quizzes, but if you do have a question for those, you can post onto Google Classroom, and I can respond to that. All right, so that is something I will try to do. I might even try to, if I can, post the actual question, the actual quizzes online. I'm trying to look into that, see if that's a way of going. Rather than emailing them all to you, I can just post them online. I think that might be the best. Okay. So, let's see. Did I get anything? I miss anything else? Now let's jump into the digestive system. All right, so here are your structures of the alimentary canal that you'll need to know. You also have the digestive accessory digestive organs that you'll need to know, be able to label them. This is an example of what kind of we'll go through. All right, not just label. So an example here is you have the large intestines. Well, the large intestines is broken into different large intestines or different sections of that large intestine. So you have the ascending, transverse, descending, sigmoid, and rectum. Okay, so those are going to be all parts of the large intestines. Okay, small intestines, you have 3 parts here. You have the duodenum, you have the jejunum, and then finally you have the ileum. And those, for the most part, are going to be the only structures that have multiple things that you need to know. Here you have the stomach. We didn't go into the different parts of the stomach. Esophagus, mouth, oral cavity. You have the tongue, teeth, salivary glands, and then pharynx up here as well. You need to know that. Then you have the liver. Okay, can go into all of those, but you need to be able to identify those. Say if I give you a diagram and arrows or whatever, you need to be able to tell me which one's which, so you need to be able to do that. But also here you have the different layers. Okay, so if you're looking at it, helps if you turn your computer on this right side, but really we're going to be talking about 4 different layers. You have the most superficial, that being the serosa layer there, that's going to connect it. Okay, then being less superficial is the muscularis, muscular layer. Remember, the digestive system is pretty much smooth muscle. Okay, and the reason for that is because it needs to be able to contract and push and move the food through the system. Okay, you don't physically do that. Okay, it's all involuntary, and it's smooth muscle, so it allows it to be able to contract the circle or the opening, the lumen of the the digestive system will constrict, and it pretty much pushes it kind of like toothpaste out the tube, starting from the bottom and working all the way up. Okay, and then it'll keep going. All right, then the next one is going to be the submucosa layer. Okay, here. All right, that's going to have a lot of the blood tissue, blood vessels, things like that, to absorb the nutrients once it goes through the mucosa layer. Okay, so those are your 4 layers. All right, you need to know those 4 layers, the tissue types of those. Serosa being a connective type tissue, areolar connective tissue, muscular or muscularis being muscle tissue, submucosa being more so connective tissue, and then mucosa layer being epithelial tissue. So you'll need to know that. Okay. Once again, you have all the organs on there. You need to be able to identify all of those, but also you need to understand the functions of all of those. Okay, so the mouth, pharynx, you can find all that going back through the PowerPoints and things like that. You may have questions on there such as match the function to the organ, kind of like the last quiz we took, or not the last quiz, but the last 2 quizzes that we took on the reproductive system, male and female anatomy, where there was no labeling on that, but it was, here's the structure, what's the function. So that's going to be part of it as well. It might be probably half of it, the other half being the labeling or identifying of that. So going into the next part, and that is the functions of the digestive system as a whole. There's a couple things I wanted to get into to have you understand. Remember, you should be writing this down, okay, on your study guide, however you want to do it. Piece of paper, it doesn't matter. You just be writing this down because there's not a lot of words on here. All right, so I'm going to go into kind of these and understand the idea. All right, so here's all your structures. Here's functions. Okay, this is a good starting point for this. Okay, so ingestion is going to happen in the mouth. That's going to be taking food in. Your teeth are going to be used into that to breaking food up. That's going to be called mechanical digestion, okay, where you are breaking it up. So digestion is breaking the food up, breaking it down, to say. So anytime chewing, mastication, anything like that, that's going to be considered mechanical digestion. Your stomach as well is going to be used in mechanical digestion as it's compresses, contracts, and relaxes, and helps to mix it up that way. Then you have your salivary glands are going to secrete saliva, and that saliva, you have enzymes in it. Those enzymes are going to help break down food, fat being one of those, as well as carbohydrates. Okay, so those are going to get broken down, or start to get broken down, through chemical digestion, chemical being a chemical that's being used to break it down. Okay, the pharynx is going to aid in swallowing. Okay, and then the esophagus is going to transport that food from the stomach, or from the oral cavity into the stomach. Stomach is going to use chemicals to help digest as well. So far, no absorption. The food has not been absorbed yet at all, and it will not be absorbed until it gets into the intestines. All right, so chemical digestion is occurring in the stomach with hydrochloric acid. Pretty much what's going to happen is it's going to secrete acid. That acid is going to help break down the proteins, since proteins are going to be a little bit more difficult, and it need a little bit more help because they have not started to get digested yet. It's going to make this liquid called chyme. That chyme then is going to be exit the stomach once it's ready, partially digested, and into the small intestine, or to be more exact, the duodenum. And then you can see here that the liver and the gallbladder and the pancreas all are going to enter here, what is called the hepatic duct. Okay, and that's when you're going to really start to get the digestion of the food. You're going to have enzymes that are really going to be specific to breaking down the macronutrients, protein, proteases, carbohydrates, lipases, nucleases. All of those proteins, are all of those nutrients are going to get broken down there, and then you're going to have absorption happening in the small intestines. Okay, so the small intestines is going to do the majority of the macronutrient absorption. Okay, and that's because of the structure of that. You're going to have these, turns and curves here. Now it's called small intestine because of diameter, not because of length. All right, these are about about 18 feet long or so, somewhere between 18 to 25 feet. Okay, but it's rather thin compared to the large intestine. Large intestine has a larger diameter. Okay, the large intestine is mainly going to absorb water as well as store feces, but also salts and vitamins are going to be pretty much your essential. It's like your last go at it, right? So you're going to absorb more. Now this passes through pretty fast compared to how far it has to go through for the large intestines. The reason why it goes through slower in the large intestines is just simply because it has to try to get all the water possible out, so that way you don't become dehydrated and stuff like that, as well as minerals and things like that. So you just want to get rid of the waste. Now, I do want to, you do need to understand something, is that when you eat something, it's not in your body until it's absorbed. Okay, we know that because if it doesn't get absorbed into your body, you get rid of it. Okay, so something that you eat and you get rid of never enters your body, so therefore it never goes into your body, and that's considered the waste. Now once it goes into your body, then it's going to be considered in your body. So I just want to get that out of the way. You have the liver. We'll talk about that separately. It has a lot of functions with metabolism. We have the gallbladder that's going to store and concentrates bile. Bile is going to be used for fats, to help break down fats, and help break down for the most part. But here you have a good understanding of what the different functions are for all the different organs of the digestive system. Some of them you can get pretty simple, such as teeth. Okay, tongue is also going to aid in swallowing, which is not on there. But I think everything else is there. The only thing you may need to understand is the different parts of these, okay, of the small intestines and the large intestines. What do they do? Are they different? The duodenum is going to be definitely a lot different than the rest of the small intestines, as this is partially digested, so it's going to be more so function of digestion. The jejunum and ileum are going to be more so functioning in absorption. Okay, so that is the functions. Here I want to go over something. It's called the gastric phase, gastric secretion. You have 3 phases, and this is all talking about your stomach acid. Okay, now your stomach acid, when secreted at the beginning, is 0.2, a 0.2 on the pH, which is extremely acidic. It's more acidic than battery acid. Okay, which that causes a lot of problems if you were to touch it and things like that, corrosion and whatnot. They say if you were to take pure stomach acid as it's secreted, a dime on a solid oak table will burn through it in like 10 minutes or something like that. So very corrosive. But how is it that our body's able to have that? Well, first off, you got to look at the lining of the stomach. It's much different than your typical lining. So if we go here, here's your typical lining of the digestive system. But your stomach's going to be a lot different than that. Your stomach's going to have a lot larger mucosa layer. Those cells are going to be a lot thicker, and they're going to secrete a lot more mucus. Okay, and they also have other cells, chief cells and parietal cells. Those chief cells and parietal cells are going to secrete certain secretions that are going to negate it. Okay, so it's going to bring that pH to a manageable, I want to say 2 or 3 pH level, which I think like lemon juice and stuff like that ends up being around 3, 4 vinegar. So therefore, it's something that we can manage. And pretty much all you're doing is taking a strong acid and using a strong base, and you're going to help dilute that a little bit, so that way your body can withstand it. Okay. So going into this, how is it that you're going to secrete juices and things like that? Well, the first is called the cephalic phase, and this happens before food is going to even enter the body. The sight of food can give you to start to salivate. Okay, so smell of food, sight of food, somebody in the kitchen. Okay, there's some sort of neurological response that is going to happen. You have the famous story of Pavlov's dog. Okay, dog sees food, they salivate. You start to ring the triangle or bell or whatever they use to notify the dog, okay, it's feeding time. And then eventually the dogs will start to salivate to the ringing of the bell, because they know that, okay, now it's feeding time. They have made that assumption that, and whenever that bell rings, I'm getting food, so therefore I'm going to start to salivate. And it's the same thing. Okay, you see the food, you hear people in the kitchen or something like that. It's close to, or maybe it's even just close to, you're getting hungry. You think about it, you start to salivate. Your body's going to start to produce and prepare for that food. Okay, the gastric phase, a lot of stuff happening here. That's because now you're going to eat. This is when food enters the body. You're going to start making all these secretions. Okay. So you're going to have the mixing of it. You're going to have stretch receptors that are going to help and aid in all of this. You have mucosa cells, Chief cells, parietal cells, G cells. They're all secreting secretions to aid in digestion of the food. And then finally, you're going to have gastrin that is going to add into all these, gastrin being that stimulating factor. Okay, so that stimulating factor is going to get used to secrete all of the other factors, hydrochloric acid, bicarbonate, all those things that are going to be used to help manage the food inside the stomach. And then you have the intestinal phase, which is the partially digested food that's going to enter the small intestines. Okay, so you have all these different secretions that are going to be secreted here as it enters the small intestines there. Okay, so once again, having to dilute the acid, because your small intestines aren't necessarily structured the same way as your stomach, so therefore you have to have some factors there to help dilute that as well, so that way you're not burning a hole in your small intestines and things like that. The liver, wow, a lot of functions here. Mainly we're going to be looking at the digestive functions, but it's going to filter a lot of blood. It's going to aid in metabolism. It's going to aid in secretions. It's going to aid in the immune system. It aids in a lot of different things. Okay, so one is going to remove potentially toxic byproducts of certain medication. That's why taking a lot of medication is hard on your liver, because it's pretty much all those toxins are being filtered out through your liver. Metabolizes or breaks down nutrients from food to produce energy when needed. Okay, so your liver is going to help and aid in that. If you have extra fat, it's going to be stored there or other places. Extra sugar be stored there or other places. Protein, same thing. And it's pretty much going to be telling your body when to start breaking down the fat, sugar, protein, or when to uptake it and things like that. So it help your body fight infection by removing bacteria from blood. Once again, cycling the blood, toxins from medication, bacteria from infection. Produces most substances that regulate blood clotting. Produces bile. So your liver is going to produce bile, a compound needed to digest fat and absorb your fat soluble vitamins. Okay, so you need fat in order to absorb these vitamins, and you need bile to break down that fat in order to. So you can see that it's a progressive type of function, right? Without the bile, you don't be able to digest fat. Therefore, you can't get these vitamins. These vitamins, vitamin A, D, E, and K, all fat soluble, are important in your body. So therefore, you need fat to break and to uptake those. Produces most proteins by the body. So when you're breaking down proteins, all pretty much that's going to go into the liver, and then your liver is going to produce those proteins. And finally, prevents shortages of nutrients by storing vitamins, minerals, and sugar. So once again, you're going to have storage there. A lot of different functions that are going to happen. The only thing, fat is going to be stored in adipocytes or fat cells, fat tissue, and then proteins are going to be made here. So they're going to be made, but sugar can be stored there as well as your vitamins and minerals. Okay, so the liver is very important in the digestive system. Okay, here you have a nutrition chart. You have the food stuff, okay, or your macronutrition. We're not going to get into too much of micronutrition, okay. So therefore, you don't have to really worry about those. You only need to know the fat soluble versus the water soluble vitamins. Okay, so ADEK, that is fat soluble, and water soluble being vitamins B and vitamin C. Okay. Other than that, we need to understand carbohydrates, protein, fat, and nucleic acids. Okay. First off, carbohydrates you're going to break down into their smallest structure, right? You're taking a large structure, breaking it down into the smallest structure, usually being glucose, but you also have three others, galactose and fructose, that can be used. So this is the enzyme and the source as far as how this is going to get broken down. So here, this first column here is going to get how it's broken down, where it's broken down, and then where it's absorbed. Okay, so you pretty much have everything there that you need to know. You have this kind of diagram here to show you kind of this breaking down of it. It's very basic. This is considered biochemistry and is a difficult subject. So I'm trying to make it as simple as possible. So once again, the path it's taking: protein, starch, and disaccharides, which are carbohydrates, fats, okay, and nucleic acids, and then it goes through this process, and things here are pretty much telling you the enzymes or the source as far as how it's going to get broken down, and then the site at where that happens. So if we're looking at it, this kind of is pretty important here as far as site of where it is, and then the path of absorption. Where is it being absorbed at in the body, right? Your body's going to use all of these. So these two are important as well as this, but more important here than anything. All right. So going through here, you have the enzymes. We'll see salivary amylase. That's going to be digestive enzyme in the mouth. Okay, that's going to aid in breaking down the carbohydrates. Then here we'll say pepsin. Pepsin is going to be in the stomach. That's going to be aid in breaking down protein. Fat digestion, we'll say pancreatic lipase. That's in the small intestines. That's going to be used to break down fats and so forth. So that's pretty much the last part of your, we're done with the digestive system. So thanks for tuning in. Your next section will be on the urinary system.